Welcome. So in this question it says, which trace best represents the relationship between friction force and normal force for an object that is moving? So let's kind of get our visualization sorted out. So here's an object and we're just going to assume its simplest thing is it's moving. It's got a certain velocity. There's going to be its weight. We can call it mg. There's going to be its normal force, and it's moving, so there's going to be, let's say, an applied force, and there's going to be a frictional force. It doesn't say if it's accelerating or if it's moving at constant speed. The important thing is it's just moving. And so what it's saying is, under these circumstances where the object is basically sliding across a surface, then how do I relate the normal force with the frictional force, which is basically this force here with that force there. And we know that, the frictional force is equal to the coefficient of kinetic friction of friction for a moving object times Fn. And well, we want to find the form of this relationship because this links FF with Fn. And so looking over here, we can see that the choices are there's going to be a kind of inverse relationship or an inverse square relationship. I can't just tell by glancing at it which it is. There's some kind of linear trace in which I go less and less and less. There's a linear trace in which I'm increasing. And then there's these two other traces here. So what's going on? And if I look, my intuition tells me that this is remarkably linear. This is like y, because that's what's on the y-axis. And this is like x, because that's what's on the x-axis. And I have a constant, which is like m. And then I've got to squeeze this in. My b is 0. There's no DC offset on this. So this is linear. So actually, in principle, I could simply look at this and say, it's linear. This is a positive value. The coefficients of friction are positive, and therefore, as FF gets bigger, Fn gets bigger, and so it's D. I actually somehow already marked that, but it's D. It's certainly not B. B would be FF gets smaller as Fn gets bigger, and there's no indication from this relationship that's the case. You would need a negative value for mu k, and they don't exist. So, and so that's how we do it. I want to go just one step further, because the first step is, can you pick a trace out of a family of traces? And the second step is, well, could you plot this? And so over on this side, I'm going to say, well, could you plot this? So if FF is equal to mu k Fn, and I said, can you plot this? Can you plot a graph of FF versus Fn? And the first question I usually get back is, well, no, because I don't know the value of mu k. You haven't told me the value of mu k. And my response for this type of analysis, where you're trying to get the shape of a graph, my response is, let's just assume a value. Well, which value shall we assume? Let's assume the simplest value. Let's just assume that mu k is equal to 1. It's constant. Why not pick the easiest one? And if that were the case, then when Fn equals 1, FF equals, when Fn equals 0, FF equals 0. When Fn equals 1, FF equals 1. When Fn equals 2, FF equals 2, and so on. Let's just take 3 points. So there's a suitable relationship. If Fk was not equal to 1, if it was equal to a half, I could just change these numbers appropriately. The problem is Not that people can't do the math, it's that they're not comfortable just picking a value. That's the issue. And so what would then happen is, in my class, if I asked you to do that, I would expect you to put FF vertically in newtons. I would ask you to put Fn horizontally in newtons. And then I'd ask you to pick some scales. So we'd have 0, 1, 2, and 3. I'd have 0, 1, 2, and 3. And then just looking at my data table, I would say, well, there's the first point, here's the second point, here's the third point, and if I change my colors just to make it stand out, and there's my trace. So that's really what I'm looking for, is that ability to be able to look at a physical situation, get a scene, and then be able, from that scene, to be able to extract the relevant equation, for example. And then from that equation to be able to go make the equation graph relationship. And sometimes that's not emphasized enough. I'd really like you to be able to go from an equation to a graph, and from a graph to an equation. Initially, the questions I ask are, pick the best trace, not a perfect trace, but the best trace. And then later on, I say, hey, here's a blank grid. You fill in what the graph looks like, but show me your data. Makes people feel a little bit uncomfortable when they're not given all the numbers, but it's a good thing to be able to push against that discomfort and be able to judge our generalizations. So there we have it.